In section 2.1, we're going to talk about relations and functions. So to start, just the basic definition of a relation is the set of pairs of input and output values. The main components of a relation are the domain, which you would think of as like your x values, and your range, which is the set of outputs, which are considered your y values and the coordinate. So here are 4 different ways to represent relations. You definitely don't need to write any of these down in your notes. I just wanted to show you 4 different ways that you'll see relations represented. So you'll see them as an ordered pair, probably most commonly like that, or a graph. In this chapter, we might look at them in mapping. You also can see a table of values. And yeah, that pretty much covers all the ways you'll see a relation. So from relations, the main thing we're going to focus on is functions. So a function is a specific type of relation where each element of the domain corresponds with exactly one element of the range. So to simplify this, for a relation to be a function, for every input there is one and only one output. So if we wanted to look at different relations and determine if they're a function, here in problem A, we see it's listed to us as a map. The domain shows us, here's our input value, and it leads to our output value. So we kind of have the coordinate -3, -2, 0 is going to 7, and lastly we have 4 is going to 1. So even though we only have 3 coordinates here, given the fact that for every input there's one unique output, that's enough for us to say, yep, this is a function. On the other hand, if we want to look at problem B, here we're given a list of coordinates as our relation, and when I'm looking to check to see if it's a function, something that I'm going to notice is that we have the coordinate 4, -1, and 4, 1. In other words, we can see that the same input gives us 2 different outputs. Therefore, this would be a relation, but it's not considered a function. Another way you can test to see if something's a function, especially if you're looking at a graph, is something called the vertical line test, which you might remember from algebra. So basically what the vertical line test states is that if you can draw a vertical line through a graph and you only hit it one time, then it's a function. But if you draw a vertical line and that graph hits that same vertical line multiple times, you're not considered a function. So for example, looking at this graph to the left, if I draw a vertical line, I can clearly see that this graph goes through that vertical line twice. So this would not be considered a function. On the other hand, looking at this other graph, even though it's kind of like a weird squiggly line, no matter where I draw a vertical line, that graph will only pass through any vertical line once. So looking at that, you can say that yes, that would be a function. And then kind of summing everything up, something that we're going to review in this section is function notation, or the function rule. So far in this class, we've been looking at graphs as like output and input values. X is our input, Y is considered our output. Something that we're going to focus on in this section is specifically using function notation. Basically, all that this is you replace Y with f of x. So then you can look at the output in terms of your input. So if I want to use like 1, say, as my input value, I can write the output as f of 1, instead of having like the x and y be totally 2 different things. So then a review of how you would use function notation. Problem number 5 asks, for f of x equals -2x plus 5, what is the output for the inputs -3, 0, and 1/4? All you're going to pretty much do here is plug in those values for x, and then we'll see what we get as our output. So for -3, I'm going to plug it into this function. So I'm going to do -2 times -3 plus 5, which will give me 6 plus 5, so I'll have 11. Then I'll have -2 times 0 plus 5, 0 plus 5 will give me 5. And then lastly, I'll plug in 1/4 and I'll get negative 1/2 plus 5, so I'll get 4.5. So this also kind of brings back the process column a little bit. I think seeing this middle column going from the input to the output can help you see, I plug in my input, I put it into the function, it spits out my output value. So tying all those things together, we're talking about relations, what kind of relation would make a function, and then finally using function notation in this section.